We will now take a look at the square root 3 subdivision scheme with a smoothing rule applied. To recap, we have this combination of splitting and flipping operations that results in us getting a mesh with more and more resolution. For the next example, each step will correspond to the splitting and flipping operations combined, plus the application of a geometric smoothing rule. Since the triangle is a planar figure, the main place that we'll see the smoothing rule in effect is at the boundary, which gets approximated to a B-spline curve. We can do another experiment where we first subdivide the triangle a few times without smoothing, and then we start applying the smoothing rule. The result is that the figure gets rounded at the edges. But 3D examples are more interesting. First, let's take a look at a sphere approximated by a number of triangular faces. We'll notice that the triangles in most of the sphere have 6 edges each. But the vertices at the north and the south pole, and also some of the vertices around those, are irregular. If we apply the algorithm, the first thing to notice is that except for those extraordinary vertices, the pattern is very regular everywhere, and each vertex has 6 neighbors. Zooming in a bit, we can also see that the outline of the sphere gets smoother and smoother. Here is the original shape for reference. And you can see clearly that the outline was very smooth. Now we'll move to a cube. If we do the algorithm, the hard edges of the cube get smoother, and the figure starts to look like a slightly deformed sphere, or a potato. Again, we can easily see the irregularity corresponding to the original extraordinary vertices, which were at the corners of the cube. Finally, we take a look at a more complicated shape, like this bunny. Since the bunny is already quite detailed, and the number of faces grows exponentially at each iteration, the last iterations might take a little bit more time. But if we zoom in, for example, at the ear of the rabbit, we can clearly see that it gets progressively smoother. Let's wait for this last iteration to finish, and I'll show you, for comparison, the original. And you can clearly see the difference. Thanks for watching.